All right, let's take a look at another problem involving mass and atoms. Um, Here we're asked to convert 1.26 times 10 to the 26 aluminum atoms to mass in kilogram. Again, our basic strategy is going to be to find some way to get to the moles, and we know that we can go from atoms to moles using the definition of Avogadro's number and a mole. Again, central point here is to get to moles. We always want to get to moles. Between moles and grams should be easily accomplished using the molar mass, and obviously kilograms should be easy after that. So let's put out our unit conversion string. And again, we're always thinking about what unit we need to cancel. So we're going to put atoms in the denominator first, so we can cancel the atoms here. In the next step, the molar mass. We'll have moles in the denominator to cancel out, and then finally grams in the denominator to leave us with kilograms. And you can see that there. Now let's put in the numerical relationships. There are this many atoms, Avogadro's number, in every 1 mole. Here's a point that I was talking about in the last tutorial. Since the molar mass of aluminum is 26.98 grams per mole, let's just round that to 27. Now, not every teacher would want you to do that, but for me it's easier, so that's why I encourage my students to do that, but obviously check with your teacher. And finally, we can use the definition of kilo to say that there are 1,000 grams for every 1 kilogram. So our answer, we get 5.382 kilograms. Seems to make sense. Again, significant figures aren't necessarily right here. We start with 2 significant figures here, so our final answer should be rounded to 5.4. And you can see that there. Now, again, common mistake would be to flip-flop the numerator and the denominator here, and if you did that, you can see mathematically you would have Avogadro's number on top. That would be multiplied by 10 to the 26th. 10 to the 23rd times 10 to the 26th would be 10 to the 49th. So you'd have a mass that would be greater than the mass of the entire Earth. So keep in mind that when you're taking a look at these problems, you always want to see if your answer makes sense, and here it does.